Alright, I'm going to apologize for the sound quality. I don't have my microphone hooked up, so this is going to sound a little weird as you go through this. I want to solve this first problem in two completely different ways. And either way would be correct on the exam. Either way would give full credit, but I just kind of want to make it clear that there's always more, or there's often more than one way to solve a given problem. So we have a situation where we have trains moving on a track. I'm going to call this the dotted train, and I'll call this the solid train. It's clear. Well, it may not be clear, but let's be sort of explicit. We're told this is 40 meters per second. That means that this would need to be negative 30 meters per second down here. Now, to be clear, the solid train is moving forwards because its speed is always positive, and the dotted train is always moving backwards. We're told that they're separated by a distance of 200 meters, so here's the situation. We're going to have this thing here with, I'm going to call this the solid train here, and the dotted train here. The dotted train is located at 200 meters. The solid train is located at 0 meters. And so what we're going to actually need to do is we're going to need equations of motion for both of the trains, because our goal is they're separated by 200 meters, they've got their respective speeds, we're going to slam on the brakes, and we're going to see how far they're separated when they both come to a stop. So to this end, I need equations for the slow train. So first, the velocity of the slow train, when I look at the graph, is going to be AT plus V naught for the slow train. And that's going to be, well, I know that the acceleration is going to be the slope of this line. That's going to be 40 divided by 5, because that's the slope. That's going to be negative 8, because the slope's negative. And we're going to times that by t, plus the initial speed, which is 40. And just for giggles, I'm going to actually do the second equation, which is the equation of its position versus time. That's going to be x equals 1/2 times a times t squared plus v naught, which is 40 times t. And we start off at 0. Now let's do a similar process for the dotted line train, the train that's moving backwards. Its equation is going to be actually, when I get the slope here, that's going to be 30 divided by 4, which is going to be 7.5 times t. And it's got a speed of negative 30 meters per second. So when we write down its equation, x dotted is going to be 1/2 times negative 7.5 times t squared. Sorry, that's positive 7.5 acceleration minus 30t. And we actually start off all the way at 200 meters on the end here. So this train, the solid line train, the one that's moving forward and stopping, it stops after 5 seconds. So we're going to plug that in there. But the backwards train, the dotted line train, it stops after 4 seconds, so we're going to need to put 4 in there. When we go ahead and do that, we're going to get that the solid train winds up at a position of 100 meters, and the dotted line train actually winds up at a position of 140 meters. So what this means is the solid train is here, the dotted train ends up at 140 meters, and so what that means is the separation distance between the two is going to end up being 40 meters of separation. So that's how we can do problem 1 using the equations, and in the next video I'm going to show you how I solve this using graphs.